Welcome to Geometry Davangere. I am Anil Kumar TRB, Assistant Professor, Department of Electrical and Electronics Engineering. So today we are going to study the experiment number 6. So that is AC voltage controller using TRIAC and DIAC combinations. These are the contents, aim of the experiment, theory, apparatus required, circuit diagram, procedure, calculation, results and graph. So aim is to study the combinations of AC voltage controller using TRIAC and DIAC combinations. Theory: an AC voltage controller using TRIAC and DIAC is widely used in the phase angle control circuit for regulating the RMS value of AC voltage supplied to a load such as lamp, heater or universal motor. So in this method, a TRIAC is connected in a series with a load and acts as a main power controlling device, while a DIAC is used in the gate circuit to ensure the symmetrical triggering of the TRIAC in both positive and as well as a negative cycle. A variable resistance potentiometer, the potentiometer and the RC circuits as the AC supply is applied to the charges through these resistors. So this is actually circuit diagram. So this is a step down transformer from 230 volt to 50 volts. Then we have the R, we have C, and we have the C1, C2. So this is called the RC triggering circuit. Along with the DIAC combinations, we are going to trigger the gate pulse of the track, that is MT1, MT2 terminals. This is the trigger firing circuits. So these are the apparatus required. That is a TRIAC DIAC module. We require the capacitors, and we require some connecting wires also. Procedure: connections are made as per the circuit diagram. Initially keep some source voltage, say above 15 volts, vary the resistor from minimum to maximum value, use CRO and measure the firing angle. So for each firing angle, measure the voltage across the track and trace the waveforms and observe in the CRO. So these are the firing angle, firing divisions. For 3 it is 60 degree and we got output voltage of 49. For 4 it is 80 degree, 44.87. So as the firing angle alpha increases, the voltage will also decreases. So this is actual graph that we have to obtain in the real-time experimentations. So this is the AC supply. We have provided 50 voltage, and this is the voltage across the capacitors. You can say this is the voltage across the capacitor after the triggering pulse. This is the triggering pulse, and this is the output voltage across the loads. And this is the output voltage across the load, nothing but across the lamp. That is what we have done in the CRO. So this is actually the SCR voltage. So these are the firing angle formula for 180. This is for half cycle, and firing division, that is shown for the 3, 4, 5, 6, 7. These are the firing divisions. So we have written, that's why it is 3 here. For alpha, divided total number of divisions, it is 9 divisions. This we can see in the CRO, to how to calculate the total number of divisions in the CRO. So alpha to 180 into 4, that is divided by 90 is 80 degree. So let alpha 3, alpha 4, alpha 5 can be calculated. So DC voltage controller using TRIAC and DIAC combinations connected to R and R loads are determined. So let us see how it works on the real time of the experiment. Let us conduct the experiment on this and see what are the waveforms we can see in the CRO. Myself Anil Kumar TRB, Assistant Professor, Department of Electrical and Electronics Engineering. So today we are going to learn the experiment on AC voltage controller using TRIAC and DIAC combinations. So we have to make the connection as per the given circuit diagrams. So in these circuit diagrams, after making the connections, we need to keep the potentiometers. So this is the potentiometer from the maximum. Then you have to vary the potentiometer from maximum to the minimum positions. Okay. So now we shall turn on the kit. So once we turn on the kit, we have to vary the pot from maximum to minimum positions. So we can see what is the output voltage across the load side, and we need to check what is the voltage in the multimeters. So now it is showing 0.09. We have to vary the pot from maximum to minimum. You can see the voltage is also getting varying, and you can see across the lamp there is illuminations. It means that we are going to control the voltage. Hence we can also observe the waveform across the CRO. In the CRO you can see there is a when I vary from maximum to the minimum position, there is a firing angle alpha will occurs. So that is, we have to calculate the number of divisions. If the pot is going to vary, we need to check how many divisions it has been crossed. That is nothing but the firing angle alpha. So let us go for the calculations. We'll go for one calculations. So this is the firing angle division 2. So I've just taken the firing angle division 2. We can observe in the CRO. I'll show you how to observe in the CRO. So this is actually the number of divisions. You can see there is a 1 and 2. So 2 divisions. Here also I have taken the 2 divisions. Here also taken the 2 divisions. For 2 divisions, we need to calculate the firing angle alpha. So that is 180. So 180 I have taken for the half cycle. You can see there is a half cycle in the CR also. So that is firing divisions. So I'll write it as a 2. And for total number of divisions for half cycle, so that is 9. You can observe how many divisions are here for the half cycle. Right. So this is for the half cycle. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 9. So that's why written as a 9. So this is 360 divided by 9. So the firing alpha will be 40 degree. So here the firing angle will be 40 degree. For 40 degree, what is the voltage? It is 48.19. Approximately 48.19. So like this we need to calculate for remaining also. For division number firing division 2, alpha 2 is equal to 180 into 3. If I take for 3 divided by 9. Okay, we need to see what is the waveform across the CR. Okay, so once we get the number of division, we need to say what is the value of alpha 2 also. So like this we need to go for the remaining value. Then we need to check what is the voltage. The voltage is around 45.773. Okay, then we'll reduce the voltage back to the minimum to maximum position. That is, we have to vary the pot. Then voltage will also get varied in the multimeter. Okay, thank you.